Welcome back to part 2 of our electron configuration series, and in part 1 we were introduced to the diagonal rule. We'll be answering more questions just like we did in question number 1, but for different elements. And the question once again reads, write electron configurations for each element. We'll start with chlorine. The first thing that you have to do here is know how many electrons chlorine has. And chlorine has a total of 17. So, looking back at the configuration here, we start off with 1s, and that holds 2 electrons. That leaves us with 15. And then we have 2s that also holds 2s2. We have 13 more to go. Going back to this, after 2s comes 2p, and that holds up to 6 electrons. 7 more left. After 2p, following this arrow, is 3s. 3s holds 2. That's 2 plus 2, 4 plus 6, 10 plus 2 is 12. 5 more left. After 3s comes 3p. And this holds up to 6. Because it holds up to 6 and we only have 5 more left, we'll just write down 5. Now we can write this down as a shortened version. If you take a look at the periodic table, chlorine's over here, and the closest inert gas is neon, which has 10 electrons. So we can write down Ne, and everything after what represents neon. So 3s2, 3p5. Notice that there are 10 electrons here, neon has 10, so you can do this for pretty much any element except you want to choose the closest inert gas without going over the amount of electrons. That's the answer to question A. Now let's do Si. Si represents silicon, and silicon has an atomic number of 14, which means that it has 14 electrons. 1s2, 2s2, 2p6, 3s2 followed by 3p2. And the shortened version will be Ne, 3s2, 3p2. The next element that we need to find the electron configuration for is Sr, which stands for strontium. And according to the periodic table, strontium has an atomic number of 38, so it has 38 electrons. Everything will be identical up until here, so let's go ahead and rewrite that. 1s2, 2s2, 2p6, and 3s2. 2 plus 2 plus 6 is 10 plus 2 is 12. So 38 minus 12, we have 26 more electrons to work with. After 3s, we have 3p. That houses up to 6. 3p6, take away 6 from that, 20 more. After 3p comes 4s, that holds 2. That's 18 left. And then comes 3d. That houses up to 10 electrons. 3d10, 8 left. After 3d is 4p, and that holds up to 6. 2 more left. After 4p, going in this diagonal, we have 5s. 5s. And since we only have 2 more electrons left, we'll write down 2. Now, we want to write this in shortened form, and taking a look at these noble gases, the closest one to it is krypton. And that has 36, so we'll write down Kr in these square brackets, 5s2. So all of this, everything to the left of this bracket, can be represented as krypton. Lastly, we're dealing with oxygen. Oxygen has 8. This shouldn't be hard. We'll write down 1s2, 2s2, and 2p4. If you want to write this in shortened form, we look to helium. Helium has 2 electrons, and we can write down 2s2, 2p4. And there you have it. 4 more examples on how to write the electron configuration of different elements.